Hey everyone, I'm Ayush, one of the co-founder of Huddle01, and I'm here with Juan Benet, CEO of Protocol Labs and creator of Lip2P, IPFS, and Filecoin.
Hey, how's it going? Great to see you.
So yeah, I think we are here for a fireside. I think we have around 30 minutes for it. So I'll get on to the main highlight of the questions which I had prepared for you, Juan. The first one was that I think on December 4th, 2013, the first commit for IPFS happened, and it completed 10 years just 2 days back. That was in Filecoin Bangalore. So I want to, and you had mentioned there in the commit that big things have small beginnings. So I'd love to understand the whole journey of IPFS when you started, when you did that commit, the what, the why, and the how. Yeah.
The whole journey of IPFS, oh man, how much time do you guys have? Maybe I'll try to focus on maybe the highlights for builders at the beginning that are thinking about some very large potential vision and thinking through whether or not to build it and so on. I've been working on a number of things before IPFS, and IPFS had a certain set of qualities where the potential was so big that it just had to be built. And I had to figure out how to build it and how to connect it to other things. While I worked on IPFS, I was also spending a lot of time thinking about other areas, including cryptocurrency. Bitcoin was now finally emerging. And then it made a lot of sense to use a cryptocurrency to incentivize the distribution. And so that gave a clear monetization pathway that enabled the creation of some kind of business around it. And so that led to really forming a good plan to be able to build and develop IPFS itself, and then separately build a strong business around IPFS that could power and fund the development of it. So I think all of that kind of got wrapped up together, and the beginning of the journey was, building the ideas, putting it together into a paper, publishing that to the world, giving some initial talks about it, developing IPFS in open source. I went through YC with Protocol Labs, and there kind of like the main pitch was Filecoin more than IPFS, because that has a very direct kind of business potential. And right after, kind of like in 2014, there was a period in a bear market in Bitcoin. So Bitcoin had a big, significant like growth in 2013. By 2014, it was already now back into a bear market. And so because of that, then instead of focusing on Filecoin, I focused very strongly on IPFS and growing the IPFS community. And we got an enormous amount of adoption very quickly, and a lot of developers jumped in to help develop the code base and so on. So most of 2014 just looked like a normal open source project where the day-to-day looked like developing on GitHub, writing a lot of issues, making PR, reviewing other people's PRs, growing the community through hanging out in IRC or conferences and whatnot. And going into 2015, that's when we shipped the first alpha for IPFS. And that started getting a lot of uptake now beyond the developers that were building IPFS. Now it became kind of a user-facing product. And especially it struck a chord with the Ethereum community that Ethereum was also developing at that time. And the concept of dApps got built there. So the emergence of a dApp was the idea that you would have this front-end application in a kind of distributed web app. You would store the single-page app on IPFS, and you would then have the smart contract backend on Ethereum. And so the whole notion of a dApp was booted up in 2015, kind of like in the early moments for Ethereum and for IPFS. And from there, of course, like the projects and the protocols grew, lots of different adoption came in, and we can talk a lot about that broader journey, but kind of that was the kind of beginning period and where the focus was.
Yeah, and I remember that you mentioned that when IPFS was launched, that you were surprised that the adoption actually majorly came from the crypto community, and you had thought that it would have been from the audience not not the crypto world, and that was pretty amazing. I think Ethereum community was the one which struck the chord with the IPFS.
Yeah, exactly. So IPFS is a pretty general technology, can be used for all kinds of uh, things. It's meant to be this peer-to-peer web. It can move around small objects. It can move around large-scale data. It it has a ton of applications. There's a lot of adoption in IPFS in, say, data archival communities that want to have good provenance on the data itself, or in the open science community where you want the papers to be addressed by a hash, and you want to be able to do open access to lots of the papers and the data and so on. And I sort of expected that developer tooling was going to be a big feature earlier on. That's happened to some extent. So people have been using IPFS for moving around software containers and VM images and so on. But it hasn't kind of percolated into package managers as much as I had expected. And instead, kind of the crypto community became like a huge adopter of IPFS and grew quite a bit with it. And it makes sense. Like dApps can't be pointing to a centralized service to host their front ends. So that of course makes sense. But yeah, that was kind of the surprising bit there.
I think moving from the IPFS, the Filecoin journey, which happened, I think, a year later, and you mentioned, and over time, I think Filecoin became the largest crypto storage network by margin. But I think that's just the first part of even Filecoin. Like storage is just the first layer of it, and you have been talking a lot about the Filecoin master plan for the last 1 year. Would love for you to maybe go into a bit of details into Filecoin master plan.
Yeah, so we've kind of broadly divided up the work in the Filecoin ecosystem into 3 stages. The first stage was to build the world's largest decentralized storage network, and we've accomplished that. Filecoin now is it's over 10 exabytes of capacity in the network, and there's I think it's over 2 exabytes now of data stored, which is a huge amount of data. Just for reference, that is vastly larger than all of the rest of Web3. The rest of Web3 is like maybe around 10 to 20 petabytes of storage, which is not very much compared to that. And 10 exabytes, that starts putting it into context with the large-scale centralized clouds. So think of like Amazon or Google or others as being in the tens of exabytes. Maybe the largest ones push into like 100. There's no good public figures for all of this, so it's hard to figure out who has what exactly. But I would be surprised if it was like much larger than that. And the whole global storage in the world is in the kind of zettabyte scale right now, right? So 10 exabytes is like 1% of a zettabyte. So that gives you a sense of like the massive scale that Filecoin has been able to achieve. There's thousands of storage providers that are building entire businesses storing data for clients. This is happening globally. There's storage providers everywhere in the world. Huge amounts in Asia, in North America, in Europe. South America and Africa still have to grow a lot. And so kind of that first phase of building the world's largest decentralized storage network has been accomplished. Now, the next 2 phases are, the next step is to bring the world storage into Filecoin. So that means onboard all of this extremely valuable data into the Filecoin network. By the way, sorry, it's super distracting to have people like taking video. Hey, thank you. It's extremely like valuable to, so where was I saying? So the next step is to bring onboard the world's data into this massive scale data storage network that we've built. So this means building a bunch of on-ramps that enable storage from many different scales to come into the network. So that means on-ramps for small bits of data. So think of like, bucket style on-ramps or personal file on-ramps and so on, to then maybe the larger scale things like groups that have petabytes or tens of petabytes of data that want to bring that scale of data storage into the network. And so the software and hardware and tools that you use to onboard those groups differ quite a bit. Like you want to enable those as separate businesses. And so that Filecoin is giving rise to a whole set of like L2 on-ramp networks that are targeting those different product areas. A part of onboarding all this data means also making it really easy and fast to retrieve. So there's a whole CDN side of this equation, which means create a content delivery network to be able to give very fast, serve the data really quickly to end users. And so that's kind of step 2, and we've been focused on that for the last year and a half, and that'll be probably the next couple of years. That'll be where a lot of the community puts a lot of focus. And the stage after that is to bring computation to the data. So that means once people have onboarded the data, they want to be able to run their computation on top of it. So that means we have to start that phase, in parallel. That began with FVM, which shipped earlier in the year. That brings smart contracts to Filecoin. FVM is this hypervisor, this WASM lower layer with EVM runtime on top, but we can add other runtimes along the way. And so that enables all kinds of storage-oriented applications. Then beyond that, we have what we call compute over data networks, where people are going to be building lots of different compute environments depending on different kinds of applications or using different kinds of technologies, especially when it comes to privacy or verifiability. There are different techniques that you might want to use. You might potentially do, in some cases you need a very hard verifiability, so you might reach for zero-knowledge proofs or something like that. In other cases, you have extreme privacy requirements, so you might reach for fully homomorphic encryption. In a lot of cases, you don't care about either of those that much. You just want really cheap, fast compute. In those cases, you can lean for optimistic verifiability. And in all of those settings, you end up with different teams pursuing these different technologies and building different compute over data networks. And so that is also giving rise to a whole bunch of L2 networks on top of Filecoin. And so we call those the compute over data networks. And then kind of like the other component here is the broad scalability of the Filecoin network. And that means we want to hit something like trillions of transactions per second. And so we're building a project called IPC to be able to get us there. And that means a very large scaling blockchain structure. So that's kind of the broad strokes of the Filecoin master plan. Build the world's largest decentralized storage network, achieved. Onboard the world's data into that network. That's in progress now. Kind of about halfway into that building the software there, and that'll be some time to onboard a ton of the data, and then bring computation to the users, which began with FEM and a range of compute over data networks on top.
Yeah, Juan, I've always been fascinated the way we have structured the whole thing, and I think this is something which a lot of Indian research institutions can take a cue from of how an R&D project, where it's proper in a hardcore research and development, how do you transition from basically just being a research paper and just writing a lot of research papers, getting a lot of citations on that, to actually making it a full-fledged company, and then from that to actually a network. I think that there is a lot of chasm you need to cross. So would love to understand from you, because we have a lot of great researchers. There's ISC Bangalore here, one of the most fantastic universities. But again, the same thing, like writing a paper and then making sure that that becomes a kind of something which impacts humanity at large scale. How do you navigate that?
Yeah, so this is what I like to call the research and development pipeline. So in that spectrum that you described, there's very early basic research that goes into extending our knowledge and extending what we know. This is broadly what we call the scientific endeavor, like the broad science effort, is to organize a lot of us to figure out more about the universe and more about the world and to come up with new ideas. And then in the complete opposite side of the spectrum, there's technologies that we want to build. So this means specific devices or components or tools, and these tools could be social structures like cities or corporations and so on. You can think of those as like technology components as well. And so those technologies are like techniques or systems that you're developing and you want broadly diffused into the world, so that the world benefits from that technology. And so of course, like as you learn more about the world, you develop a better understanding of things, and it gives you an insight for what new technologies to build. And as you build new technologies, you gain you enhance our capabilities, and you enable us to discover even more. So there's a self-reinforcing feedback loop, which is behind the great progress of human civilization over the last few thousand years. Now, this process tends to be pretty slow. Like when you come up with something new and you make a new scientific discovery, sometimes it takes somewhere between 10 to 20, sometimes 30 years for that scientific development to turn into something that can be put into technology and eventually put into a product to be sold at mass scale. And there's kind of naive understanding more in academia, where there's this impression that once you come up with a big discovery, just sort of like the work is done and you can move on to go discover something else. And in reality, that's just the beginning of getting that scientific discovery into a technology that could eventually be put into a product and then sold at a mass market. And so the foremost research institution in history, in recent history, was Bell Labs. And Bell Labs had this notion that you haven't really innovated unless you've sold the innovation at mass scale. So what does that mean? You need to not just come up with a scientific discovery, you also need to figure out how to put that into a device at very low cost. So you have to figure out how to manufacture the thing, how to make it cheap enough to produce, and then how to put that into a set of products that are going to benefit from this new device or this new component to then give some new capability to users or a big cost reduction. And then at some point, you go through like the distribution of that and create a market for it and deploy it into the world. And so the researchers and scientists at Bell Labs had this perspective that if you haven't gotten your insight all the way into people's hands at mass scale, that's not really innovating. And I take the exact same view, that we really need to develop not just our scientific understanding, but we need to translate the science into technologies and products and scale them. And so when you think about this whole structure, you can think of all these different stages, early research, fundamental development, productionizing, then building products themselves and scaling them, all of those stages as having different people, different organizations, different structures. And so today, kind of the world of technology startups is the latter part of that pipeline when you start building a product and then scaling it. And the early part of that pipeline tends to be academia, science, or open source development, side projects, and so on. And kind of in between these two, there's a big gap that people commonly refer to as the valley of death, where like good ideas go to die, because there isn't a lot of funding in those early stages of fundamental development. There's a lot of funding for startups and technology building because that's very close to a market and products and revenue flows. So that whole area of the pipeline is working really well. And there's also a lot of funding for fundamental science for the early stages of research, because lots of governments know that it's really important to develop scientific understanding, so there's funding there. But in the middle, there isn't good funding structures today. The academic credit doesn't flow all the way to this kind of like second or third order research. And so there isn't, as a scientist, you can't make a great career by adapting and developing some insight. So there's no strong incentive there. And for startups, that's way too early. There's no product there yet. You have to refine some early technology. So there's no fundamental utility for a lot of startups to develop there. Sometimes some of the best and most important startups end up being started there, but it tends to be very few startups by number that end up kind of operating in that layer. Now, the VC could stretch back into that area, but to do so, VC funds would have to be about 10 to 100x larger or have a 20-year time horizon, and they just don't. VC funds tend to be in the 100 million to single billion range, and they have a 10-year time horizon, which means that they really can't afford to invest that early. And so that gap is the gap that I find the most interesting to build components in, and where a lot of our focus at PL is figuring out structures to support that technology translation of what has science now enabled us to do that wasn't possible before, and what needs to get developed into new technologies and components, upon which you could then go build startups. And there might be multiple startups that are yielded out of some fundamental technology improvement. And so this, I consider like a super valuable area to develop, to invest in, and so on.
Yeah, I think I was recently at a All-In Summit, which happened in Las Vegas and Los Angeles actually, and I saw there were two two entrepreneurs sitting, and they were discussing about nuclear fusion. I think Helion and one more, and they were discussing about the exact same thing. Where they were Vinod Khosla and all the Khosla Ventures and other kind of people sitting, but the kind of enormous amount of money which you need to fund this fusion kind of startups is huge. So either you have to cross that VC toward and work with the funding structures like sovereign wealth funds and stuff like that. But I think we need some kind of more innovations there. So I think one thing was that when equity structure came into picture by Silicon Valley, and then came the SAFT, which happened in 2014, which was a new structure for funding the crypto networks. We might need something else as well, which also helps in making sure that these kind of impactful things happen.
Yeah, it's a very insightful point. Is like you can create financial instruments to cover that area, and yeah, I think that's absolutely a thing that we can do. So let me give you a few examples of some that we've thought through. So in that area, because you're pre-startup often, and you're investing in really scientific technology development teams that don't yet know what the products are going to be, but they're refining the technology, you need to be ready to invest capital without that turning into a startup straight up. And so there's a structure that has been developed in the last few years called a focused research organization, an FRO. This is similar to the CROs, like the consulting research organizations, which are a well fleshed out concept in biotech. So FROs are a structure to form a team of scientists and technology developers to describe the technology program and the plan they're going to make, and create basically a little company in a sense. It ends up being a nonprofit company, but a little company to just go and do this technology development to achieve the scientific results, so the technology development results. And there's a set of funders that you can pitch that to, who will agree that that's an important thing to do, and they then deploy the capital for their own reasons. They know that there's not going to be direct financial ROI from there. Now, separately, of course, there's IP development there, and so you could take that intellectual property that you're developing and turn that into something that you can then sell. Now, it's very tricky because if you treat that as IP for a startup, often you'll get it wrong, because usually the early teams that are developing that part of the technology may not be the best teams to then go build the startup. So another structure that you can develop here is what we're calling a fundamental development fund, where you can create, you can invest in these FRO type programs, get the IP, and then enable a lot of startups to build on that IP afterwards. So that's, think of adapting the VC style construct, but for that early stage. We'll see if that ends up working. This is kind of early days. Maybe checking back in 5-10 years from now would be like the right time frame to figure out whether these FDFs ended up working. A good example of one actually that's in the Web3 space is VitaDAO. VitaDAO is effectively an FDF. They invest in early science, they develop some IP, and they work with startups to commercialize some of that technology. But again, super early days. The results will be visible 10, 15 years down the line. Now, another kind of instrument that you could create is coming up with other ways of funding and paying for people in working in this area. You can think of doing credit assignment, of figuring out what worked on what, who worked on what parts, and if it ends up being really valuable work, then paying them then. So this is called retroactive funding structures, and so I think retroactive funding structure could actually work in this area. It's difficult. Not everyone has the individual advantages to be able to work in that mode, but this could actually work in this area. There's also an adaptation of the SAFE that I think is viable, where you could give. I've seen a number of these where you could give a SAFE early on to a group, assuming that it's just research funding, but if it does turn into a startup, then it becomes, then it just turns into equity. I don't think that SAFE as it is today is perfect for it, especially because it doesn't handle this notion of like, what if that team that you're funding isn't actually the team that's going to go on to commercialize the technology. If these are two separate teams, you have to reason about that in a transaction. And it's also a structure that doesn't work for scientific labs in universities. Those have to be like gifts according to kind of how universities work today. So there's an open space there for new kinds of instruments. The other thing you can do, of course, is to change the nature of the IP transaction. So my view is that IP is like extremely bad. It is an extremely bad transaction today. like there's lots of good reasons for it to exist. When you think about bio, if enormous amount of development goes into figuring out a drug, like you think of the small molecule development or something like that, and you might be spending millions to tens of millions of dollars worth of value in getting to that stage. And once you come up with a compound, then anyone can freely copy it and produce it for basically for free, in a sense, right? Using the structure that they already have. So their IP is critical in order to be able to pay for that underlying initial development. Now, in software, you have the opposite end of the spectrum, where software patents tend to be extremely frivolous and kind of ridiculous. You get into these cases where things like the one-click buy sort of thing ends up being patented, and you disable. You're literally preventing other things from improving greatly. And so you end up in a world where the software industry as a whole has been very negative on patents for good reason. They just sort of create this really, really bad environment. So my sense is that, and likewise, in all of this, you never really hear of individual inventors who are, have a normal profession in their day-to-day lives that is just inventing things and producing IP and then selling it in the market, right? Like, I can't point to a single person that I know who does that as a job. They just invent things, file patents, and then sell them. And so there's something fundamentally broken about that transaction. That transaction only benefits mega-scale corporations or these startups that are trying to eventually protect themselves from some big company taking it over. And so maybe there's something about the IP transaction itself that could evolve, that could change. For example, it might be removing the kind of like full excludable right, or removing the ability to just prevent somebody else from using the patent, meaning there should one structure that you could employ here is to always have a price for a patent. You define a price on the patent, and maybe that price keeps decreasing over time as you get closer to the expiration date. And at any point, anyone can go and buy it. Or you could use auctions with that kind of structure, right? Like you always have a live running auction, and whoever pays for that patent is able to kind of use the patent and so on, and kind of buy a license. But if nobody's interested in it, then the price of it is very low, right? So, but you can create a structure where you don't end up in this environment where it's just extremely difficult to create that transaction as something that people could actually use. The other thing I think with patents is really dangerous is you should never be in a position where patents are inhibiting the use for extremely important humanitarian causes, right? So there's all these very bad examples where patent law is just broken in terms of what makes sense for the world. Like you shouldn't use patents to hold entire civilizations or countries hostage from being able to make vaccines and save lives and so on, right? Like there of course should be a way of making sure that the value required in order to develop the technology is there. So we have to make sure that there's funding flows appropriately, but at the same time, there shouldn't be a situation where you get this price gouging, inhibiting, preventing millions of lives from being saved or something like that.
Yeah, I think this is amazing. Looking forward to these new structures which will help. And I'll see more startups like Helion and all the others who are doing some impactful things in climate change, nuclear fusion and other kind of things, which we have been hoping to happen as early as possible. I think just shifting gears to the last question, which is more on the lines, I think you have been spending considerable time in India for the last 2 years. And also startups like Hurdle One, Secured Finance, like a lot of them, which I can see here, have actually come through that whole builder's journey, the funnel which has been created by the Protocol Labs team. Would love to understand from you, and there's more than, I think, 30% of the startups, founders are from India as well. So would love to understand from you, have you seen any kind of, have you noticed something where you see that in this builder's journey, Indian founders are able to thrive in some kind of situations? Would love to understand that.
Yeah, so I'm a huge fan of India and Indian founders and startups. So India has a lot of advantages here. So first off, super high education rates relative to a lot of other places in the world. You have super knowledgeable people. You have super knowledgeable institutions. You have some of the best schools in the world. You have also great connectivity. So that means India invested very deeply in connecting the whole country, leapfrogged the rest of the world in terms of not going into broadband and instead going straight to cell networks, which was a very good move. And so you have like high connectivity for the whole country. So that means everyone is able to access all of the learning that you can get from the internet. So that's a superpower already. And they can access the global markets. They can access lots of people worldwide and so on. And then you also have like this, kind of by purchasing power parity comparison, just kind of the same value here extends a lot further than in other countries. So you have kind of an environment where you have people like students, professionals, builders that have the same capabilities as the best people anywhere else in the world, but you end up with like a much lower cost overall of building a startup in general, because you as founders and builders can make the money run further. Which means that you have this crazy advantage when it comes to fundraising. You don't have to raise as big rounds to accomplish the same kinds of things. Or you can raise the same kind of round and then scale up much more than other groups do. Sometimes I see Indian founders being like, oh, we should like move out of India and go somewhere else. And I'm like, oh, that's giving up your advantage. Like, don't do that. You can be in the internet, connect with everybody else, like definitely participate in the global community and engage with lots of people elsewhere. But don't give up your advantage of being able to like just have this, when everybody else is struggling for money, you have like this super advantage in not having to pay as much. Now, instead, what you should do is like use the equity to give all of the people working with you a huge slice of what's going to be really valuable in the long term, and that way you can then bring, once you succeed as a startup and you generate a lot of value, then at that point you bring a lot of wealth into India and you diffuse it into the economy, right? So I think like that's kind of the advantage that you have. The other thing that I think is super exciting here is just there's a strong like developer-oriented culture of working on the hardest, most interesting problems, like deep knowledge in distributed systems and networking, which a lot of that came from helping build a lot of the infrastructure of the internet and working with lots of the large internet-oriented companies like Cisco and Google and friends. There's also lots now that we have Web3 in the mix. There's also a lot of interest in the deep cryptography side, so zero-knowledge proofs and FHE and other things like that. And so that ends up being like super interesting to see in a lot of builders. And so what I would kind of encourage teams here to do is to think of like the really strong suit that you have with the people here. Find ways of composing strong teams and develop like really high quality products and build your startups straight from here, because you'll get like this really successful advantage. So yeah, that's my perspective. I think we're super excited in general about all of the activity and development we see in India. We think it's a phenomenal place to build, lots of brilliant people, and also in terms of wealth generation events, I personally would much rather see wealth generation events happening in places that need it the most, right? Like if you enable a startup here that sells into the world to generate a lot of value, and then a lot of that value gets diffused into the economy here, that needs it much more than, say, like a super wealthy country. In my book, that's like a net win for the world. And so I think like huge fan of all of the startup builders here in India, and excited to support you as we can. The whole PL network has a whole bunch of programs to support builders across many different stages, from early moments where they're just kind of thinking about ideas and hackathons and so on, to they actually have like a good concept for a business and they're figuring it out, and maybe accelerator stage, and they're validating the thing. Or when they actually have now a product with product market fit, and they're starting to like now build the early stages of a proper startup, and so that goes into kind of like seed rounds and so on, or later stages once they're kind of growing into A, B territory. So for each of these stages, we've structured a number of programs to support founders and builders and the people in those startups developing across those stages. So very excited to keep working with you and many other amazing builders here. And in fact, I think your story, like you telling your story more to lots of the builders here and the communities here, will help inspire the next generation of builders.
Yeah, one, I think I can see Saksham sitting right in front of me. He's also from PL network itself, from Long Hash. I think these kind of stories really help in also going further into the whole ecosystem itself. So thank you so much for everything, and thank you so much for imparting the knowledge. With that, everyone, 1 minute.
Thank you very much. Thanks for having me.